Find the sum to n terms of the following series. Let us begin. So here we have a series with first term being 1, followed by the second term, that's 3. Then we have 7, then we have 13, followed by 21 and the rest of the terms. Now clearly this is not an arithmetic series because we cannot find any common difference here. However, if we take the difference, that means if we take the second term and from here subtract the first term, that's going to give us 2. Taking the third term and subtracting the second term from it gives us 4. Taking the fourth term, which is 13, and from here subtracting the third term, that is 7, so that's going to give us 6. Then we have 21 minus 13, so that's going to be equals to 8. So here clearly we observe the 2, 4, 6, 8. Now these terms are forming an arithmetic progression, which means here we can find out the sum to n terms by taking the help of the method of difference. So what is the method of difference? For this, let's assume the series is denoted by Sn, with Tn being its last term. If Tn is the last term of the series, then Tn minus 1 is going to represent the previous term to that of Tn in the series. We're going to take the same sum Sn, and we have 1 plus 3 plus 7 plus 13 going all the way up to Tn minus 1 plus Tn. Okay, now what we'll do, we're going to perform a subtraction now. So on the left hand side, we have Sn minus Sn, so that's leave ourselves with 1, 0. Then we exclude the first term of the first series. Let's keep it as it is. We have 1. Next, what we do, we take 3 minus 1, so that's going to be 2. 7 minus 3, that's 4. 13 minus 7, that's 6. 21 minus 13, that's 8. And this goes all the way up to, this is positive here, all the way up to Tn minus 1, and then we have negative Tn. We'll transpose this Tn to the left hand side to get Tn equals to 1 added to 2 plus 4 plus 6 plus 8, going all the way up to Tn minus 1. Now clearly, from the second term onwards, all the way up to the last term, this is an arithmetic series whose first term a, that's 2, the common difference, that's 2, and then we have n minus 1 number of terms present. Now the question is, why do we have n minus 1 number of terms and not n number of terms? Now, if we consider the first Sn, so here what we do, we excluded the first term 1 and we included the second term all the way up to the last term. Now by definition, Sn has got n number of terms, so the moment we exclude one term, we'll be left with n minus 1 number of terms. Similarly, for the second sum Sn, we excluded the last term of the series and we included everything from the first term to the second last term. So here also we have n minus 1 terms, and that's why after taking the difference we obtain n minus 1 terms. Now we know that the sum to n terms of any arithmetic series, that's given by the formula the total number of terms divided by 2, which gets multiplied to 2 times the first term added to the total number of terms minus 1 times the common difference t. Now let's use that formula. So Tn will be equals to 1 added to the total number of terms n minus 1 divided by 2 multiplied to 2 times the first term added to n minus 1 minus 1 times the common difference 2. Let's simplify this to obtain Tn. So Tn is going to be equals to 1 added to n minus 1 over 2 multiplied to, so we have, and 2 times 2, that's 4 added to, so we have n minus 2 multiplied to 2, so that gives us 2n minus 4. So here we can factor out 4. We can cancel out 4, and that's going to leave us Tn equals to 1 added to n minus 1 times n. So here we have Tn equals to n squared minus n added to 1. So this is going to be the nth term of the series. Now that we have the nth term, we can use this information to obtain the sum up to n terms. Now we know that the sum up to n terms, that's simply given by summation of the nth term of the series, but we're going to replace the index n with k such that k runs from 1 to n. In other words, what we are trying to do here is trying to find out the summation of k squared minus k added to 1, where the index k goes from 1 to n. And that means we now have summation of k squared with k going from 1 to n minus summation of k, again k goes from 1 to n, that means there are n number of terms, added to summation of 1 with k going from 1 to n. Now summation of k squared, this is the sum of the squares of first n natural numbers. We have a standard formula for this, that's given by n multiplied to n plus 1 times 2n plus 1. This is going to be divided by 6 minus summation of k. This is the sum of the first n natural numbers, which is defined as n times n plus 1 whole divided by 2 added to. Now summation of 1 means we have 1 added to itself n number of times. So this is simply 1 multiplied to n, which gives us the value n. Okay, now we're going to combine the three terms, and that's going to give us the final value of Sn, which comes out to be n over 3 multiplied to n squared plus 2. So this is going to be the sum to n terms of the given series, 1 added to 3 plus 7 plus 13 plus 21 all the way up to n terms.